myself Kalma, lecturer in mathematics in K.B.N college. Now I am going to teach a topic in a discrete mathematics 2. It is a topic for the first BVOC students. In this I am going to teach about the first unit, functions and graphs. In that, the first problem is, it is given y is equal to 5 plus 3x minus 2x square. Then we have to find the value of y corresponding to the given x values. Here x is given from minus 3 to 3. That means just we have to substitute the values of x in the given expression y. The first one is x is equal to minus 3. Now we have to substitute that minus 3 in the given equation y equal to 5 plus 3x minus 2x square. See, first the value is y is equal to 5 plus 3 into, in the place of x we have to substitute minus 3. Then we get 3 into minus 3. The next one is minus 2 into, in the place of x we have to substitute minus 3. Then we get minus 3 whole square. After solving the next case we have 5 plus, next 3 into minus 3, it gives the result minus 9. And minus 2 into minus 3 whole square. Minus 3 whole square means minus 3 into minus 3, that value is 9. Then we get 5 minus 9 minus 18. Here we get 5 minus 9 minus 18 means minus 27. Then the result is 5 minus 27. Then y is equal to minus 22. We get the value of y equal to minus 22 when we substitute x is equal to minus 3. In the same process we have to substitute x is equal to minus 2. Then we get the value y is equal to 5 plus 3 into minus 2 into minus 2 whole square. Then we get 5 minus 6 minus 2 into 4. Then we get 5 minus 3 into minus 2 means minus 6, and minus 2 into minus 2 whole square means 4. Then we get the result 5 minus 6 minus 8. Here now we have to add minus 6 minus 8. Then we get minus 14. That means the result is 5 minus 14, which gives the results minus 9. That is, when we substitute x is equal to minus 2, we get the result minus 9. In the same way, we have to substitute x equal to 0. That means in a place of x, we have to substitute now 0. Then we get the result y equal to 5 plus 3 into 0 minus 2 into 0 whole square. Then the result is clearly it's a 5. And next time we have to substitute x is equal to 1. Then we get the result y is equal to 5 plus 3 into 1 minus 2 into 1 square, which results y is equal to 6. It's a general solving. And next x is equal to 2. Also y is equal to 5 plus 3x minus 2 into x square. Here in place of x we have to substitute 2. Then we get the result 5 plus 3 into 2 minus 2 into 2 square. Here 2 square means 4, 3 into 2 means 6. Then the result is 5 plus 6 minus 2 into 4. 2 into 4 means 2 4s are 8. Then the result is 5 plus 6 minus 8. Then the result is 11 minus 8. And then we get the result y equal to 3. That means when we substitute x is equal to 2, we get the result y equal to 3. And last we have to substitute x is equal to minus 1, and the result is y equal to 0. Now last one is x is equal to 3. When y is equal to 5 plus 3 into 3x minus 2 into x square, now we have to substitute x is equal to 3 in the place of x. Then the result is 5 plus 3 into 3 minus 2 into 3 square. 3 square means 9. Then we get the result 5 plus 9 minus 2 into 9. 2 9s means minus 18, and 14 minus 18, the result is minus 4. When we substitute x is equal to 3, we get the result y is equal to minus 4. In this way, we have to solve the next problem. Here it is clearly given f of x is equal to x square plus x minus 6. Here the same values are the same. In the first question, we have elaborated that x is equal to minus 3, minus 2, minus 1, 0, 1, 2, 3. In this problem, it is directly given that x is equal to minus 3 to 3. This is also the same process, but it was given in a short form, that is x is equal to minus 3 to 3. Now we are given f of x is equal to x square plus x minus 6 for the values of x is equal to minus 3 to 3. That means here the given value is f of x is equal to x square plus x minus 6. We have to substitute the x values from minus 3 to 3 in given the function. First value is x is equal to minus 3. The given function is x square plus x minus 6. Now substitute the value minus 3. Then we get the equation minus 3 whole square plus minus 3 minus 6. Minus 3 whole square results 9. Then 9 minus 3 minus 6, which gives the result 9 minus 9, which is equal to 0. Here it is given the graph. To find the graph, we have to plot the points in such a way that x-axis on a y-axis. For that purpose, we are writing as a point x comma y. Here given x value is minus 3 and we get the result while substituting the x is equal to minus 3 is 0. So that's why the x comma y can be written as minus 3 comma 0. Similarly, we are finding the value of x is equal to minus 2. Then the function is minus 2 whole square plus minus 2 minus 6, which results 4 minus 2 minus 6, which is equal to 4 minus 8 minus 4. Then the result is x comma y is equal to minus 2 comma minus 4. That is, while substituting x is equal to minus 2, we get the result minus 4. And the point becomes minus 2 comma minus 4. Similarly, we do for x is equal to 1 and x is equal to minus 1 and x is equal to 2. The first one is x is equal to minus 1. When function x is equal to minus 1, when the function result is minus 6, then we get the point x comma y, which is equal to minus 1 comma minus 6. Similarly, we do for x is equal to 0. That means we have to substitute x equal to 0 in the given function f of x, which is equal to y equal to 0 square plus 0 minus 6. That means 0 plus 0 minus 6 is equal to minus 6. That means the given point becomes, when substituting x equal to 0 is minus 6. Therefore, x comma y is equal to 0 comma minus 6. Now substitute x is equal to 1 in the given function y, that is 1 square plus 1 minus 6, which results 1 plus 1 minus 6, which is equal to 2 minus 6, which is equal to minus 4. While substituting x is equal to 1, we get the result minus 4. Then the point is x comma y equal to 1 comma minus 4. And the next point is x is equal to 2. When x is equal to 2, the function is 2 square plus 2 minus 6, which result 4 plus 2 minus 6. 4 plus 2 means 6. 6 minus 6, which results 0. That means at the point x is equal to 2, we got the function y is equal to 0. Here we plot the graph. In horizontal, we took the x-axis. In vertical axis, we took the y-axis. First, we have to plot the points of the x-axis and then plot the second function y-axis. The first 2 points results the same. And at final, we have to find the x equal to 3. And the next problem is the sum of two numbers is 28 and there is a difference in 12. Then find the numbers. Here given, first we have to assume the two numbers. Let x comma y be the two numbers. Here given hint is the sum of two numbers. That is, while adding those two numbers, we have the result 28. And the difference means while subtracting those two numbers, we have the result 12. Then means let x comma y be the two numbers. Here given that one, the sum of two numbers is 28. That is x plus y equal to 28. And the difference of two numbers is 12. That is x minus y is equal to 12. Let it be equation 1 and equation 2. Now we have to solve these equations and find the values of those two numbers, that is x comma y. The first equation is x plus y is equal to 28. The second equation is x minus y equal to 12. Now just we have to add those two equations, which results x plus y equal to 28 minus x minus y is equal to 12. Then y get cancelled, then we get 2x is equal to 40. By solving that, x is equal to 40 by 2, that is x is equal to 20. Here we get the first value x is equal to 20. We have to substitute in equation 1 or equation 2. Here I am taking the equation 1. Just substitute the x is equal to 20 in equation 1. Then we result 20 plus y equal to 28. Then we get y is equal to 28 minus 20, that is y is equal to 8. Therefore, the given numbers are 28 comma 8. And the next problem is the sum of three consecutive integers is 24. Then we have to find those integers. Consecutive numbers are the corresponding numbers which come after, that is x comma, x plus 1 comma, x plus 2 are the suppose we assuming that these three are the consecutive integers. By solving the given, by taking the hint, you have to find the value of x. Here the given that the sum of three consecutive integers is 24, that is x plus 1 plus x plus 2 is equal to 24. Now we have to do the general addition, then we get x plus 1 plus 2 is equal to 24, that is 3x plus 3 equal to 24. Taking a 3 on a common side, then we get 3 into x plus 1, which is equal to 24, that is x plus 1 is equal to 24 by 3. And 3 get cancelled in 24 for 8 times, then we get x plus 1 equal to 8. Then x is equal to 8 minus 1, which result x equal to 7. Now we have to find the next two consecutive numbers, that is x plus 1, that is 8. Then x plus 2, that is 9 plus 8. 7 plus 2, that is 9. Therefore, the three consecutive integers are 7, 8, 9. We find the consecutive integers by giving the result that sum of three consecutive integers is 24. And the next problem is solving the linear equations. Here it is given three linear equations and three unknowns. And given equations are x plus y plus z equal to 6, x minus y plus z equal to 2, 2x minus y plus 3z equal to 9. Here we have to solve these three equations to find the unknowns x, y, z. Here we are doing the general solving, that is from the first equation 1 and 2 we are just adding the equations, that is x plus y plus z equal to 6, x minus y plus z equal to 2. After adding these two equations we get the result 2x plus 2z equal to 8. Then solving it, 2 into x plus z equal to 8. Cancelling on both sides, 2 with 2, then we get the result x plus z equal to 4. For the purpose of the next equation, we are taking it as a equation 4. Now we are adding equation 1 and 3. To convert the equations only in the x and z term to solve these two equations. Now we are adding the equation 1 and 3, then we get x plus y plus z equal to 6 and equation 3 2x minus y plus 3z equal to 9, which gives the result x plus 2x means 3x plus y minus y means 0 plus z plus 3z is equal to 4z and 6 plus 9 equal to 15. Then we get the equation 5, that is 3x plus 4z is equal to 15. Here we did this addition just to convert the three variable equation into two variables, that is x and z. Then we get from the equation 1 we have x plus z equal to 4. From the equation 5 we have 3x plus 4z. To make the variables in common, multiplying the equation 4 with the 3 and multiplying the equation 5 with 1 just to make the first terms equal and to get the subtraction. And the first equation becomes 3x plus 3z is equal to 3 fourths 12. And next fifth equation becomes 3x plus 4z equal to 15. Now we have to subtract these two equations. Then we get 3x plus 3z is equal to 12 minus of 3x plus 4z is equal to 15. Then we get the result 3x minus 3x, which is 0, and 3x minus 4z, which is minus z, and 12 minus 15, which is minus 3. Cancelling the minus on both sides, then we get z equal to 3. Now substituting this z equal to 3 in either in equation 4 or in equation 5. Now I am choosing the equation 4, that is x plus z is equal to 4. In that equation substitute z equal to 3, then we get x plus 3 is equal to 4. Then by solving x is equal to 4 minus 3, that is x is equal to 1. Here we have the values x equal to 1 and z equal to 3. Now substituting these two values in equation 1 to obtain the value of y. Then we get x plus y plus z equal to 6, that is 1 plus y plus 3 equal to 6, that is y plus 4 equal to 6, that is y equal to 4 minus 6, that is y is equal to minus 2. To verify whether it is right or wrong, we have to substitute in one of any equations given. And then we go to the next method, that is mathematical induction. Here we have to follow one method to solve these mathematical inductions. The first one is, when the given problem, we have to follow the 3 steps to find the mathematical induction of a given equation. The first one is, we have to consider the given equation as a S of n. Then we have to substitute n equal to 1 in a first step. And in a second step, we have to assume that if the condition is true for all integers k belongs to capital N. And in third condition, we have to prove for k plus 1. By following this method, here we are solving the mathematical induction theorems. The first one is prove that mathematical induction for all integers small n belongs to capital N, and the given expression is 1 plus 2 plus 3 plus n so on plus n is equal to n into n plus 1 by 2. In the method, first we have to assume that the given expression is s of n. That is, when come to the proof, we have that s of n is equal to 1 plus 2 plus 3 plus n so on plus n is equal to n into n plus 1 by 2. In a step 1, we have to put n equal to 1 in LHS. In RHS, we have to satisfy the condition should be true for 1. First put n equal to 1 in LHS. Here in LHS, we have the n value is n, which is equal to 1. In RHS, we have the value n into n plus 1 by 2. Now substitute n equal to 1 in place of n. Then we get 1 into 1 plus 1 by 2, which is 2 by 2, which is equal to 1. And LHS value we have 1 and RHS value we get 1. Therefore, LHS equal to RHS. Therefore, the condition is true for all 1 belongs to n. Next, in the step 2, we just assume that the condition is true for k. That is, assume that s of k is true for all k belongs to n. That is, in a place of n, we are substituting k and the condition is satisfied. That is 1 plus 2 plus 3 plus n so on plus k is equal to k into k plus 1 by 2. And in step 3, we have to prove that s of k plus 1 is true for all k plus 1 belongs to n. From the equation 1, we have the term 1 plus 2 plus 3 plus n so on k is equal to k into k plus 1 by 2. From that equation, we know the kth term. So, since by equation 1, the kth term is k. To find the k plus 1th term, we have to substitute the k plus 1 in the place of n. Then we get the k plus 1th term is k plus 1. Now adding this k plus 1th term on the both sides of the equation 1, then we get 1 plus 2 plus 3 plus n so on k plus 1, which is equal to k into k plus 1 by 2 plus k plus 1. Now we have to solve in such a way to get the result in the s of n. That is k plus 1. In the right hand side, we have that k into k plus 1 by 2 plus k plus 1. Now we have to take the common k plus 1. Then in the first term we have k by 2 and in the second term we have 1. That is k by 2 plus 1. Now take the general LCM, then we get k plus 1 into k plus 2 by 2. Now in the second part we have k plus 2. We can write it as k plus 1 by 2. Now we have to compare this with the given question. Then the given question is 1 plus 2 plus 3 plus n so on n equal to n into n plus 1 by 2. Here in place of n, we proved that for k plus 1. That means s of k plus 1 is true for all k plus 1 belongs to n. When these three steps can satisfied, we can say that by the principle of mathematical induction, s of n is true for every n belongs to n. Hence, therefore, 1 plus 2 plus 3 plus n so on n equal to n into n plus 1 by 2. Hence proved. And the next theorem is and here given the theorem 2 is prove that by mathematical induction for all integers n belongs to n, the condition is a plus ar square plus n so on a into r power n minus 1, which results a into r power n minus 1 by r minus 1. That is, the equation should have to prove that by the mathematical induction. Similarly, we have to follow the method. In the proof, in the first step, we have to take that given expression as s of n. That is, let s of n is equal to a plus a into r plus a into r square plus n so on a into r power n minus 1, which is equal to a into r power n minus 1 by r minus 1. In a step 1, we have to substitute n equal to 1 and have to find whether it is satisfied or not. Now take the LHS. In the LHS, the nth term is a into r power n minus 1. Now we have to substitute the value of 1 in the place of n. Then we get a into r power 1 minus 1. 1 minus 1 means which results 0. which is equal to a into r power 0. We know that if r is not equal to 0, then r power 0 value is 1. Then we get the result a into 1, which is equal to a. Now we have to take the RHS. Here RHS value is a into r power n minus 1 by r minus 1, which is equal to a into r power 1 minus 1 by r minus 1. R power 1 means r. Then we get the result a into r minus 1 by r minus 1. And r minus 1 in the numerator and r minus 1 in the denominator get cancelled. Then we get the result a. Therefore, the given LHS value we get the a and RHS value is a. Therefore, LHS is equal to RHS. That means the given condition is true for every 1 belongs to n. That is, S of n is true for all n1 belongs to n. Now in the step 2, we have to assume that the given condition is true for all k belongs to n. That is, a plus a into r plus a r square plus and so on, a r power k minus 1 equal to a into r power k minus 1 by r minus 1. Let it be equation 1 for the next purpose. Now we have to find the value for s of k plus 1. From the equation 1, we have the kth term is a into r power k minus 1. By using that, we have to find the k plus 1th term, that is a into r power k plus 1 minus 1, which results a into r power k. Now we have to add this k plus 1th term on the both the sides of the equation 1. And the equation 1 is a plus ar square plus and so on, a r power k minus 1 plus a into r power k, which is equal to a into r power k minus 1 by r minus 1 plus a into r power k. Here we have to add a into r power k on both sides of the equation 1. Now we have to solve the right hand side of the given expression in such a way to find the result as s of n. Then we get a into r power k minus 1 by r minus 1 plus a into r power k. We are taking a as a common, then we get a into r power k minus 1 by r minus 1 plus r power k. Now we have to take the LCM of r minus 1. Then we get a into r power k minus 1 plus r power k into r minus 1 by r minus 1. When the new bases are equal, we have to must add the powers. Then we get the result a into r power k minus 1 plus r power k plus 1 minus r power k by r minus 1. After getting the solving that equation, r power k minus r power k gets the 0. Then we get the result a into r power k plus 1 minus 1 by r minus 1. Now we have to compare this equation with the given s of n. The given s of n is a plus ar square plus and so on, a r power n minus 1 is equal to a into r power n minus 1 by r minus 1. Here in place of 1 n, we have find the k plus 1. Therefore, the given condition is true for all k plus 1 belongs to n. That is, s of k plus 1 is true for all k plus 1 belongs to n. By finding these three expressions, we can clearly say that by the principle of mathematical induction, s of n is true for all n belongs to n. That is, a plus ar square plus and so on, a r power n minus 1 is equal to a into r power n minus 1 by r minus 1. Hence, proved.